Hi, this is Sung. I'm your online maths mentor. Again, we're going through the topic on permutations and combinations. We're starting off working through permutations first, and what we have done is we've gone through the general formula to work out the total number of arrangements, right? Because you know, like I've been drumming in, permutation just means the number of arrangements where the order matters, yeah? And then what we did in the last episode was go through some common variations, and we looked specifically at the first type of variation that I highlighted, and that is the variation of restrictions and how that affects the way we use the formula. The next way, or the next common variation that affects our use of the formula in basically calculating different arrangements is groups within groups, right? And the best way to kind of illustrate that is with an example. So let's have a look at a specific example on the board. So there's a number of parts. There's like 1, 2, 3, 4, 5 parts. Hopefully my hope is that by the time we do part 5, you will have cottoned on to basically know how to deal with things, right? So this is the sort of, students find this this topic particularly frustrating because it's the sort of topic that is caught rather than taught. It's rather than kind of learning set formula from a textbook. You've got to really kind of intuitively think about things and kind of use your intuition to kind of see how that applies to the specific question. And that basically comes from experience a lot of the time. So let's actually have a look at some of these examples here, and by the end of it you should have a good idea of how to deal with groups within groups. Okay, so let's have a go at that. All right, so the question is this: how many ways can 3 boys and 3 girl prefects be arranged to sit at the front row of a school? Okay, well, this one's fairly simple, right? 3 boys, 3 girl prefects, they're all unique individuals, right? As a Monty Python clip would suggest. All right, so you got 6 individuals. So the answer to part 1, right, is how many arrangements can there be of 3 boys and 3 girls? The answer is 6 choose 6. Now, 6 choose 6, right, is actually 6 factorial. They're actually the same thing, right? And the reason why is because you have 6 seats, and then you also have 6 prefects. Ignore the fact that they're boys and girls at this stage. You've got 6 prefects, so basically you can fill the first position with 6, you can fill the second position with 5, 4, 3, 2, 1, and then we blast off, right? So basically you've got 6 P6. In other words, you've got the permutation of choosing 6 from 6 people, which is exactly the same as 6 factorial. Now, you probably can't see that well there, so let me just write this. There we go. That's probably a little bit better. All right, so you've got 6 factorial, right? So that's the answer to the first one, okay? Good. Let's have a look at the second one, and this is where groups within groups becomes important, okay? What if the boys sit in a group and the girls sit in a group, right? So here's what we've got in this particular example. We've got things happening here, right? You've got your boys group, and then you've got your girls group. So how many groups do you have, right? You have 2 groups. You've got 1 group and you've got 2 groups, right? How many ways can you arrange 2 groups? Well, there's 2 ways that you can arrange 2 groups. Got it? However, so you can either have, so the 2 ways that you can arrange the 2 groups are either boys and girls or girls and boys. Do you see that? So that's the larger group. And then within the larger group, you have smaller groups. So you've got the group of boys within the larger group, which is the group of boys and girls. Does that make sense? So how many ways can you arrange the 3 boys within the boys group, right? Well, you've got 3 boys, 3 can fit into the first choice, 2 can fit into the second position, and 1 can fit into the third position. Yes? So basically you've got 3 factorial. Yeah? And then you've got the same thing for the girls. How many ways can you arrange the 3 girls? Right? The same thing. 1, 2, 3, 3, 2, 1. You've got 3 factorial. Right? So, for the second question, right? What if the boys sit in a group and what if the girls sit in a group as all 6 of them sit in a line? Well, the answer will be 3 factorial times 3 factorial times 2 factorial, which ends up being 3 factorial is 6, 3 factorial is 6, 6 times 6 is 36 times 2, which is 72. Now, yeah. So, does that make sense? So, for part 2, you know, if the boys sit in a group and the girls sit in a group, you have 72 ways of arranging that, okay? Which is much less than 6 factorial, which ends up being, that's what, 120 times, which is 720, right, which is 10 times less than the number of ways, right, that you can arrange the boys and the girls if they're just sitting in any random sort of arrangement. Does that make sense? Good. Well, let's have a look at part 3 now. What if the boys need to sit together as a group only? All right. Well, this is how we do it, okay? So basically we have 3 girls and we treat the group of boys that constantly have to move together as one element, right? So as one group. So you've got one boy, you've got girl, girl, girl. But you don't have one boy, it's one group of boys where you've kind of got a group of boy 1, boy 2, boy 3, but you've got these 4 elements in the bigger group, and you've got 3 groups inside this element, which makes another group. Does that make sense? All right. So, for part 3, what if the boys need to sit together? Well, this is the boys group. This is 1 girl, 2 girls, 3 girls. We're going to rearrange all of these 4 elements within and amongst themselves. How many ways are there of arranging 4 girls within a group? Well, the answer is 4 factorial. Does that make sense? So in other words, you've got 4 elements, 1, 2, 3, 4. There's 4 ways of arranging those, so 4 factorial ways of arranging those elements. But within this element, you can actually have 3 factorial versions of this particular boy group. Does that make sense? So you need to take the arrangements of the bigger group and multiply by the number of arrangements of the smaller group. Does that make sense? All right. So what you end up with is 4 factorial, which is 24, times 3 factorial, which is 6, and your answer should be 144. Got it? And that's the number of arrangements there. Okay, good. Let's have a look at part 4, right? And what I might do to do part 4 is rub this out. So just bear with me here. So the answer for part 1 was 720. The answer for part 2 was 72. The answer for part 3 was 144. And the answer for part 4, which is what we're going to work out, is what happens if the boys and girls sit alternatively, right? So basically you've got 1, 2, 3, 4, 5, 6 positions. Yep. And here's what we're going to do. All right. Can you see that even if you've got alternating boy, girl, right? So this is boy 1, boy 2, and boy 3. And this is girl 1, girl 2, and girl 3, right? Do you see that you've basically got two groups? Yeah, you've got the group of boys, which will occupy the first, third, and fifth seats, and you've got the group of girls, which will occupy the second, fourth, and sixth seats. Does that make sense? Cool. Now, what we need to take into consideration is how many ways are there of arranging these three boys in those three positions? And the answer, of course, is 3 factorial. Does that make sense? All right. Then we multiply by the number of arrangements there are of these 3 girls in the even positions, yeah? Which is 3 factorial again, yeah? And then we multiply and then we get our answer. Does that make sense? Not quite, okay? Because there's one more other step that we need to do, and if you're perceptive, you will have realized this. We've got here boys occupying the even position, the odd positions, and the girls occupying the even positions, yeah? We also have another variation of that, and that is when the girls occupy the odd positions and the boys occupy the even positions, right? So we need to take this answer and multiply by 2. Does that make sense? Right? So really, how many ways are there of arranging the seating of the 6 prefix so that you've got boy, girl, all right? Well, the answer will be 36, 3 factorial times 3 factorial. How many are there of arranging it so that it's girl, boy? Well, there'd be 36. Add the 2 together. In other words, we're doubling it, and we should get 3 factorial 6 times 3 factorial is another 6. 36 times 2 is 72. Now, what you will notice is that seating the 6 prefix alternatively is exactly the same as seating the prefix as 3 boys together and 3 girls together, or vice versa. Does that make sense? Because essentially, the only difference is that we're making the positions alternate rather than putting the positions together, but the number of arrangements that fit into those positions will be exactly the same. Okay? So the answer for part 4 is 72. Got that? Let's do the last one. The boy captain and the girl captain must take up the first 2 seats. All right? So this is a classic example, right, of kind of where the restrictions and the groups within groups kind of you're kind of doing both things at the same time, yeah? And let me show you how that particular thing works. So you've got the boy captain, you've got the girl captain, this is position 1, this is position 2, and then you've got 3, 4, 5, and 6. 3, 4, 5, and 6. Right, now, what you've got is you've got the boy captain and the girl captain, and they need to occupy these 2 positions. Got it? All right. So how many positions, how many choices can you make for position 1? Well, the answer is 2. It's either the boy captain or the girl captain. Okay. So captain boy, captain girl. Yeah. All right. So they're the 2 choices that you can place into position 1. How many choices can you place into position 2? Well, you can only place one choice in position 2, and it's whatever's left over after we've made this selection here. Does that make sense? Good. So you multiply these 2 together. Then what you've got left over is you've got 2 boys and 2 girls, right? So in other words, you can put 4 people into position 3, 3 people into position 4, 2 people into position 1, and 1 person into position, the last position, right? So 4 people into position 3, 3 people into position 4, 2 people into position 5, and 1 person into position 6, yeah? So what is the answer for part 5? All right, so if the boy captain and the girl captain must occupy the first two seats, well, we have 2 times 4 factorial. Does that make sense? Or 2 factorial times 4 factorial. Now, what's 4 factorial again? 24. 24 times 2, the answer is there'll be 48 arrangements, there'll be 48 permutations where the boy captain and the girl captain take up the first 2 seats. Okay? Now, did you get an opportunity to really get a feel for how to do groups within groups? Right? What you've got to do essentially is work out your external arrangement. Right? So work out how many elements there are in the overall big picture, and then work out if there are any internal arrangements within the external elements. All right? And then you've got to multiply the number of internal arrangements with the number of external arrangements. Yeah? So it kind of gets a little bit tricky. What I want you to do is, if you didn't get this, go back, re-watch the videos. I know I went a little bit fast, but you will have the opportunity to slow it down, re-watch it, do what it takes to really get a handle on it. And then in the next episode, I will go through the next variation, and that is identical elements. Thank you very much for watching.